Hello, today we're going to work on lesson 9.2, which is factoring quadratic expressions again. However, these trinomials are going to be a little more complicated. They are going to have a leading coefficient or an a value that is different than 1. So what we want to do today is we want to factor quadratic expressions in the form of ax squared plus bx plus c when the greatest common factor is 1, and we're also going to look at some where the greatest common factor has to be factored out first. Okay, so we'll see a couple different types. I think the way that Springboard presents these problems looks really challenging, and I can show you lots of different ways that we can get these trinomials factored without having to do too many guesses and checks. And then I'll also show you another method for getting our solution. So for our first quadratic, 2x squared plus 7x plus 6, okay, notice that this one is different because our a value is not equal to 1 anymore. So that we say that our a value is that coefficient of x squared. So now that our a is 2, we have to think about that when we're factoring. Okay, so if I were to not even look at this big box they have here, but instead just kind of think about how I would start factoring this expression, I'm going to put my parentheses out. There are some things that have to be true that we know. So for example, the first times the first quantity has to multiply to 2x squared. The only way to do that is to use 2x times 1x. Okay, there's no other options for multiplying to 2x squared. The other thing that is absolutely necessary is the signs. So we know that our two numbers have to multiply to positive 6 and that our outers plus inners have to add to positive 7. So we do have to use both pluses. So the next thing we need to do, this is the part that we're going to be guessing and checking with. So I would suggest using pencil when you do this kind of a problem so that you can erase. Okay, so if I know that the last times the last has to multiply to 6, well then I'm going to put in some things to try. So I'm going to start by using 3 times 2. And so if I use 3 times 2, let's say I put 2 here and 3 here. Okay, so now my first times my first works, my last times my last works, I need to check my outers plus my inners. My outers are 2x times 3, which is 6x. My inners are 2 times x, which is 2x, and that's close, but that does not equal 7x, that equals 8x. So I need to try again. So what I'm going to do instead is work on changing that around a little bit. Instead of using 2x, then 3x, 2, then 3, I'm going to use 3 and 2 and check and see if that works. So now, again, I have 2x times x, which is 2x squared, 2x times 2, which is 4x, 3 times x, which is 3x, that does make 7x, and 3 times 2, which is 6. So my factors are 2x plus 3 times x plus 2. So we can't any longer just say, I need to find two numbers that multiply to 6 but add to 7 because we have this 2 now in front. And so we have to consider it as we're factoring. Okay, so if we try the next one in example B, again, I'm going to kind of ignore the box just because it's a good practice problem. Let's try working on 3x squared plus 8x minus 11. So there's some things I know that have to go in here. Okay, so first times the first has to multiply to 3x squared. So that has to be 3x times x. Okay, it's not negotiable. Now our last term times our last term has to multiply to negative 11. So numbers that multiply to negative 11 have to be 1 and 11. Some sort of 1 and negative 11 or negative 1 and positive 11. And we have to keep in mind that the outers plus the inners have to add to positive 8x. So we have to try a couple things. So 11 and 1. So let's say I put 1 here and 11 here. Not even going to put the signs in yet. Let's just see what kinds of products we get. So 3x times 11 is 33x. That feels awfully big. And then 1x, well, 33x and 1x, even if you're subtracting, it's not going to get you an 8. All right, so instead I'm going to try to switch the 1 with the 11. So let's put the 11 here and the 1 here. And let's see how things are changed now. So now my outers are 3x and my inners are 11x. Okay, well, we can get an 8 from a 3 and an 11, definitely, if we do some subtraction. And we do need to use a minus sign, so we just have to figure out where we want that minus to go. Okay, so if we have a negative 3x and a positive 11x, so negative 3x plus 11x is 8x. So I want my 3x to be negative, so I'm going to put my negative here. I want my 11x to be positive. I'll put my positive there. Now I'll check my FOIL to make sure I'm right. So 3x times x is 3x squared. Outers plus inners, 8x. Last times the last, negative 11. So our answers are 3x plus 11 times x minus 1. And that's what they finally come up with at some point. Oh, I think they got it here. So 3x plus 11 and x minus 1. All right, so these just take practice, and we call it the guess and check method. So we've got a few up here we're going to try now in the try these. So let's take a look at the first one. I'm going to work on the side so I have some room to do some practice. Okay, so part A. I've got 3x squared plus 5x plus 2. So since it's a trinomial, I'll draw my two binomial factors, and I'll start thinking about how I can FOIL back to that expression. So first times the first has to multiply to 3x squared. So that's 3x times 1x. Okay. And I know I have to multiply to positive 2. Okay, so positive 2 would have to be 1 and 2. So let's see if I get it right. So that's 6x and 1x. Yeah, they could make a 5x, but unfortunately, I need both my signs to be positive, and that's not going to work. So I need to switch it up a little bit. So what I'll do now is I'll replace the 2 and the 3. So I'll make it 3x plus 2, and I'll make it x plus 1. And now let's see if that works. So now I have 3x plus 2x, and that gives me 5x in the middle. So it factors into 3x plus 2 times x plus 1. Look at part B. So part B, we have 2x to the second plus 5x minus 18. So let's try our quantities. And 2x times x is 2x squared. Now I'm a little nervous about that 18 because there's a lot of ways to get 18 to multiply to 18. Okay, so let's just start trying them. So I know that I can use 9 and 2. And I know that I could use 6 and 3. I know I can use 18 and 1, but I'll save that for last if I want to. So what I want to do is I'm going to start with 9 and 2 and see if I can make it work. Well, if I put 9 here and 2 here, okay, I have to get signs in here too. So let's just say I put a minus here and a plus here. Now, why did I pick two different signs? Well, think about, I have to multiply to negative 18. So I need to have two different signs. I need to have one of them negative and one of them positive to multiply to negative 18. So let me try my outers and my inners. My outers are 4x. My inners are minus 9x. That is negative 5x, which is really close. I wanted positive 5x. So that's an easy switch. I'm really glad I tried 9 and 2 first. Can make that one plus, and we can make this one minus. And now it's negative 4x, but it's plus 9x, and that is positive 5x. So we do have 2x plus 9 and x minus 2. And those are our factors. Let's look at part C. I'm going to go up here and use part C. So let's set up our quantities. I know this has to be 2x times 1x, which is 2x squared. For 7, I can only use 7 and 1. So that's a little nicer than 18. So let's say I use 7 here and 1 here. Will that make a 6 in the middle? 7x and a 2x. Not even with subtraction will that work. Okay, so let's try to switch the 7 and the 2, or the 7 and the 1. So we'll put our 1 here and our 7 here. Okay. Now it's 14x and 1x. So anyway we put in 1 or 7, it doesn't seem to work. We can't make that middle term. We don't have any options left. When that happens, then we say that this polynomial is unfactorable. But we tried. We could say prime, or we could say that the polynomial is unfactorable. Okay, all right. There's a couple more. We'll save these ones and try these so we have some to do in class. Then example D is going to be it's going to be the first time we see some problems in which we have to do a GCF first before we start to factor. If you notice in example D, there is a 9x squared minus 24x plus 12. And those three terms do have a common factor. They're all divisible by 3. If your trinomial, any polynomial, can be factored with a GCF, you should do that because that will make your polynomial much easier to factor if the coefficients are smaller. So I want to encourage you to always take out the GCF. And you have to do it at some point to get a final answer. So let's look at a couple of these in the try these. I'm going to look at part A first. Let's go over here. And we have 10x squared plus 19x plus 6. Okay, well, this polynomial doesn't seem to have a GCF. So let's see if we can get it factored using our guess and check technique. For 10x squared, we could use possibly 5x times 2x. For 6, we could use 3 and 2. Okay. Well, I will probably put my 2 here and my 3 here, and let's see if we can make that work. I need to get a 19 in the middle. There's 15x, there's 4x, and I'm supposed to use 2 pluses because the original problem has 2 pluses. That one is done. Part B, however, where we have 8x squared plus 20x minus 28 has 3 terms that can all be divisible by 4 in this case. 4 will go into all of those terms. Start by factoring out that 4. Then you're left with 2x squared plus 10x plus 5x, and minus 7. The polynomial has much smaller coefficients now, but I do want to caution you not to lose your original factor. It has a 4. You want to keep it. Now we'll play around and see if we can get this factored. 2x times x is 2x squared. 1 times 7 is 7. One of these has to be negative. I don't know which one yet. We'll just check our outers and inners to see. Well, the outers is 14x. That feels too big. I don't think I put the 7 and the 1 in the right spots. So I will change those two. Let's make this the 7 and this the 1. And if I check my outers and inners again, now I have 2x with a 7x. Okay. Well, 2x with a 7x can make a 5x since I do have to use a negative, but I want the 5x to be positive. Well, it means I'm going to put my negative here, my positive here. That way I have a plus 7x and a minus 2x. That does make a positive. Factoring out that 4 first did help us a little bit, so you must do that first. Let's do one more example. Let's do part C, which is 8x to the third. So this one is not a quadratic expression right now. It's 8x to the third plus 14x squared plus 6x. If you don't see a quadratic expression, it probably means you can factor out an x. I do see an x in all three terms. And all three terms can also be factored out by a 2. We'll take out a 2x, which will leave us with 4x squared, a little smaller to deal with, and then minus 7x plus 3. All right. Well, we did the GCF portion. Now we have to check to see if the trinomial can factor. I'll make my quantities. This time it's a little trickier because 4x squared could actually be handled a couple different ways. We could do 2x times 2x. We could do 4x times 1x. Let's play around with it a little bit and think about what has to be true. Well, our last term is 3. We know that has to be 1 times 3, but it's positive 3. And our middles have to add to negative. So two numbers that multiply to positive but add to negative, at least I know that these have to both be negative. So 1 and 3, and they have to both be negative. But to multiply to 4x, I'm going to start with, I usually start with 2x times 2x. Let's see if that works. I see negative 6x and negative 2x. That is negative 8x. That does not work. Okay? And even if you switch 2 and 2, they're still the same. Well then, if 2x and x did not work, 2x and 2x didn't work, we're going to have to try 4x with 1x. And now I have negative 12x minus 1x. That doesn't work either. Okay, well, we could try to switch the 1 and the 3. Maybe that'll work. Sometimes we have to switch things around. We put the 3 here and the 1 there. If that doesn't work, then it's probably prime. Well, the outers are 4x, negative 4x. The inners are negative 3x. It does work. That is negative 7x. We do end up with a set of factors, and there's 3 factors there. We have the 2x in front. We can't lose that as part of the factors. 4x minus 3 and x minus 1. These just take a lot of practice, and we will be